Find the slope. Very good. How do I find slope? Y equals mx plus b. That's going to be an equation for a line. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to need how many points? 2 points. So can somebody help me find 2 points here? What do I got? No, I can't. It says find the average rate of change over the interval -2 to 4. -2, 20, good. Very good. Okay, so now I'll use my slope formula. 6 minus 20 divided by 4 minus -2. And I get -14 divided by 6, which is -7/3. That is my average rate of change. Okay? It says, over what two consecutive integer values is the average rate of change the greatest and the least? Looks like my smartboard's locking up here. We're not going to do the alignment, but I didn't realize you could reset it back here. Somebody showed me that. All right, so over what two consecutive integer values is the average rate of change the greatest? So meaning the slope the greatest between two integer values, okay? Consecutive. What would be the slope if we were to find it between these 2 points? -10, right? How about here? -8, -6, -4, -2, +16. So it's greatest between what two values? 3 and 4. It is least between which two values? -2 to -1. Here it was -10, and here it was -2. If I do 10 minus 20 over -1, yep, okay. So I know some people may say, well, 20 or 10 would be steeper. I'm not talking about steepness. I'm talking about least value. It says greatest to least. So furthest to the left on the number line. And furthest to left on the number line would be -10 out of that. Okay, what is the instantaneous rate of change of the function at x equals 1? How do you get that? Okay, so this is the input, x, this is the output, and then f prime is the derivative, or the instantaneous rate of change. So it says, what's the instantaneous rate of change of function at x equals 1? Yes, it is -5. What is the derivative of the function at x equals 3? -3. Instantaneous rate of change and derivative are the same expressions. What is the equation for the line tangent to the function at x equals -2? What two things do I need to write an equation for a line? Slope and a point on the line. Okay, let's generate the point on the line. What's the x value? What's the y value? Yeah, 20. What's the slope? So therefore, y minus 20 is equal to -12 times x plus 2. Minus 4. What is the equation for the line tangent to the function 0, 7? I'm sorry, at x equals 0. What is the y value? What's the slope? So isn't 0, 2 just a y-intercept? So y equals -7x plus 2. finally, what is the equation for the line showing the average rate of change over the interval -1 to 3? What would I do there? The slope? How? Using the 2 points. So what are the 2 points? So -10 minus 10 over 3 minus -1. I get -20 over 4, which is -5. So I know that the average rate of change is -5. It says it wants the actual equation for the line that shows that. Just pick one. Yep. So I'll go y minus 10 is equal to -5 times x plus 1. Or y equals -5x plus 5. What do you think about that? You good? Okay. Let's flip it over. And let's get to example 6. I know that the numbers are out of order. Over the years, I've deleted examples and I filled ones in, and I don't always go back and check the numbers, see what I got. So let's go to this piece. We're going to now describe a derivative in terms of context of the problem. I'm making macaroni and cheese. Anybody love macaroni and cheese? Like that's your okay. All right. So Maddie, if you're like not feeling well, you're at home with a cold, you probably just make the macaroni and cheese. You have that for breakfast, lunch, supper, right? Pretty much. Ramen. Ramen's your thing. You like mac and cheese too? Okay. So we'll do mac and cheese. Like if I got nothing to do for the kids for supper, I'll pull out some frozen chicken nuggets and some mac and cheese, and we'll do that. Yeah, the one that has shapes on it. Dinosaurs. or maybe I would even if I'm really desperate, I do macaroni and cheese. I'd cut up a hot dog and like put it. Yeah, raise your hand. Raise your hand if you do hot dog in macaroni and cheese. Okay, all right. Raise your hand if you were forced to do the hot dog macaroni and cheese. Like you start, like mom and dad would say, we're having macaroni and cheese. And you got excited, but then you found there were hot dogs in it. And you felt like crying inside. Like you were. Okay, all right, okay, all right. Yes, Michael. Okay, all right, okay, all right. So Maddie's at home. She's got a pot of water and she's turning the oven on. Okay, she's turning the stove top on. Okay, and she doesn't know how to cook, so she puts the pot of water in the oven instead of the stove top, and she reaches in and grabs it. She burns her hand. It's all over. Okay, no. All right, so it's on the stove top. She turns it on. Okay, and it says that the temperature of the pot of water is modeled by the function C equals F of M. So C is degrees in Celsius. She's a metric freak, so she's not going to go Fahrenheit. And M is time in minutes, okay? So it says, explain in simple terms what F prime of M means, okay? When I see prime, what keyword should come to mind? Derivative, instantaneous. Instantaneous what? Rate of change. The rate of change of the temperature in degrees Celsius per minute, right? But it means more than that. Am I looking for an average rate of change or an instantaneous rate of change? So that means that it's at a specific time, right? So at time n. All right, m minutes, that's fine. So let's put it in real context here. Maddie's boiling water. And she starts texting out to the class, hey, f prime of 5 is 10. What does that mean about her pot of boiling water? Awesome. Close, but not correct. Is this the time or is this the temp? This is the time, right? So at 5 minutes, stupid smartboard. The temperature of the water is changing. At what rate? Is the temperature going up or is it going down? It's going up. How quickly? The temperature is changing at a rate of 10 degrees Celsius per minute. Now, I'm going to give some examples here, okay? I once did a checkpoint on this. A student back in class said, was it okay if we have a different word, or if we have it worded differently? It's basically the same thing. And I said, well, let's try that. Why don't you read it off? And they said, okay, well, I have basically the same thing. It just says, after 5 minutes, it's gone up 10 degrees. I'm like, that is entirely not correct. Okay, that is entirely wrong. This does not mean that at 5 minutes that finally that water has risen from, say, 40 degrees to 50 degrees. That's not what it means. Do we have any idea what the current temperature of the water is? It could be 5 degrees Celsius. It could be 90 degrees Celsius. We don't know. Do we know what the starting point of the temperature was? We have no idea. All we know at that time is it's going up at a rate of 10 degrees. Okay? I'm driving on the highway. I've been driving for 3 hours, and I'm driving at 60 miles an hour. Do you have any idea how far I've driven? Do you have any idea when I'm going to stop? Do you have any idea how many miles I've covered? Any idea where I began? Do you know how fast I'm going? 60. That's what you know. That's what this is. Try next one. Distance runners traveled modeled by D equals F of H. D is distance miles, H is time in hours. Explain what F prime of H means. The rate of change of what? Of the distance. What do we measure that in? In miles per hour at time H. Explain in simple terms what F prime of 3 equals 5 means then. At what time? At 3 hours, the distance is changing at a rate of what? 5 miles per hour. Which basically means at 3 hours, what's his speed? 5 miles an hour, okay? Now, we can't relate everything to speed, okay? But here's the things that you have to have, folks, as you're writing it, okay? At a specific time. This is extremely important. Don't say over the course of a given time or over the span or in this time frame. No, it's at that time, and make sure that you put a label and make sure you use the term rate. Extremely important. You try the last one on your own. should have something to the nature of the rate of change of the mass in grams per day at d days. Somebody have something different that they want to try out? Sure. All right. We'll do that when you get back. Go get some brain food. Come back. All right. So F prime of D means the rate of change of the mass in grams per day at D days. So explain in simple terms what F prime of 2 equals negative 3.4 means. That means at what? At day 2, yep, or 2 days. At day 2, the mass is increasing or decreasing? Decreasing. That's fine. I'm going to clarify that. Decreasing at a rate of 0.34 grams per day. So if I said the mass is changing at a rate, if I said changing, then I would need to put negative 0.34. If I say decreasing, that absorbs the negative value. We all okay with that? The important pieces you have to keep in mind, you must have the rate label, you must say at, and you must, use the word rate. Okay? Those are required. Are we all clear on that? Okay, so flip it over. We're not going to do this top part, really not necessary. You know definition 2 already. We've kind of already practiced that, haven't we? So you like definition 2? You like the algebra? Good, good. We are going to do some algebra then right here, okay? And this is a word problem. Forgive me regarding the negative time interval that we have. It's not really possible, but I guess if, the beginning of the year is time 0, then it's, before that, whatever. Particle moves along a straight line, okay? And the position of the particle can be given by this guy. S is equal to 5t squared minus t minus 3. Okay? It says it wants to find the velocity of the particle at those times, okay? Sorry about that. I was watching the Gophers beat the Hawkeyes. I was getting excited. So anyway, find the velocity at those times. Now, remember when we found velocity, what we did is we identified A, and we did A plus H, right? We would have to do that 3 times. It'd be kind of a pain in the butt to do 3 times, right? So let's not do it 3 times. Let's just do it once. Okay? The velocity is the position, or I'm sorry, the rate function. So if you take the derivative of distance, you get the velocity. Velocity is the rate of change, right? We just talked about that on our previous problem. There's a distance runner. He's running. What is the derivative of the distance or the position? Well, it's his speed. So if we want to find the velocity, we take the derivative. We use this guy. The limit as h goes to 0 of f of a plus h minus f of a all over h. The formal definition of the derivative. It gives us a rate of change. Okay? So, I need a point. Normally, you'd select -4. How would you get the y value? You'd plug it in. Instead of selecting -4, I'm going to select A. If I plug A in, what do I get? Thank you. So now I have the limit as h goes to 0 of f of a plus h. 5 times a plus h squared minus a plus h minus 3. Then I have to subtract off f of a, which is 5a squared minus a minus 3. That's all over h. You guys remember, because we practiced this already, but doing it last year, if it doesn't have an H, it should cancel. Yeah, so we want to anticipate that as we work everything through, because well, everybody should know this. If I plug in 0 right now, what would I get? 0 over 0. That's what we would get. So we have to divide off that discontinuity. So let's try that, okay? I distribute the 5 after I square it. What do I get? 10AH. 5H squared minus A minus H minus 3 minus 5A squared plus A plus 3. Thank you. All over H. Very good. As we said, if it doesn't have an H, it should cancel. Does that happen? Yeah. Notice that back here, these are all pieces that don't have an H. So you should be able to tick all those off, hopefully, right away. Does everything else have an H? So can we divide the H off? The discontinuity is then removed. So I have a 10A, I have a 5H, and I have a minus 1. Can I then plug in 0 for H? What happens when we plug in 0 for H? Zero for H. And instead of coming up with a numerical answer, you get an algebraic expression, 10A minus 1. That's your rate of change function. That's the derivative. Instead of expressed as a number, it's expressed as an expression. So now it says, find the velocity at these times. Well, how do you think I find the velocity at -4? You just plug it in. And I should really have a label. The line says the particle is moving. S is measured in meters, T is in seconds. So it looks like we've got meters per second going on here. The velocity at time 1 be 9 meters per second, and the velocity at time 3, 29 meters per second. So we didn't have to do it over and over again, did we? We didn't have to do it 3 times. Just did it once. Now, it got a little bit lengthy with those variables, but it was all good. Okay? So there you have it. Get rid of this. Okay? Just 4, 7 through 9, and 25 through 28. The problems are not just 100% identical to the notes. That's on purpose. I want you to have to try to think about a couple pieces as you put this together. If you can't, don't worry if you need to ask questions. This is the assignment that people most often put off to the end. They have questions, they never get them answered, and then we begin to struggle. Because you're going to get a worksheet on Monday, you'll get a worksheet on Tuesday, and those are the ones that you'll try to fly through. Whereas this one, make sure that you ask questions, please, if you're not getting it, okay? You didn't have much of an assignment yesterday. Just add this to the assignment from yesterday, and you know, do it during the Hawkeye game, okay? The assignment from yesterday was what, 3, 5, and 6? Yep. It could be road.